NASA is trying to go to the moon again, but this time the mission is slightly different. In fact, this time in 2024, when they go to the moon mission, it is going to be the precursor to all the other future missions where they go and have a settlement on Mars or other planets. And in order to do that, and also they want to create a launch pad in space. So, in order to do that, what they have done is that this time the moon mission is not going to be on the near side of the moon. It's going to be on the far side of the moon. And as you know, that the moon is phase locked with the Earth. And so there's one face of the Earth, or one face of the moon that constantly faces the Earth. All the missions so far have been on the near side of the moon, which means that whenever you have a mission, you can just create a or have a dish antenna, and then the dish antenna can point towards the Earth, and you can either wait for your mission control center or station to face the dish antenna, and so then you can communicate, or you can have different Earth stations that are situated in different countries. This time the mission is very different. This is going to be on the far side of the moon. So first of all, you never see the moon base, and the only way that you will have the communication with the far side of the moon is going to be indirect. So what they are going to do is that just like we have satellites on the Earth, they are actually going to launch CubeSats. Those CubeSats will be circling around the moon, and they will provide essentially position navigation timing. They will do science missions. They will do sensing missions like synthetic aperture radar and things like that. They will also have these relays. So these relays are constantly providing relay communication. And the moon mission this time that NASA has got different services. So just like we talk in the 5G, we have service level or service oriented architecture. NASA also has got a service oriented architecture. So they've got position navigation timing. They've got networking services, science services, as well as the detection services. So detection would mean weather patterns. If there's a solar flare that happens, what happens in that case? So it is a pretty complicated mission. They also plan to have a gateway. And so the gateway would be located about 100,000 kilometers from the moon and 300,000 kilometers from the Earth. And that gateway would be manned. So in fact, there would be people on the gateway that would be doing all kinds of science experiments. The other thing that makes it very complicated is that you have lots of different countries that are involved. So you got United States and NASA, which is involved. You got the European Space Agency that is involved. You got the Japanese Space Agency. You got the Indian Space Agency, the ISRO, as well as I think they're going to collaborate with Chinese as well. And so you can imagine that all these different countries, they will bring their own equipment. They will have their own supply chain, as Admiral Simpson and Bob talked about. You have different supply chains, so different radio manufacturers. If you look at the radio spectrum requirements that NASA has this time, it goes and spans from UHF band all the way to Ka band. So you can imagine that some companies, they are going to bring the radios that will operate in the UHF band. And some companies, they're going to bring it in the Ka band. And so now you need to cater to all these different radios in a small size, weight, and power and low energy budget. And so how do you make that happen? So it is a very challenging mission. And so, what Aeronaculus is doing actually is to provide a cognitive control plane. That control plane will help to basically enable the networking infrastructure. So it's a very exciting project, and we are hoping that we can continue to work on that and expand.